in next time we will use the polynomial division. So s squared plus 4s squared plus 6s plus 4 is equal to s plus 4 plus 2 s squared plus 4s, sorry, 2s plus 2. So we will use the polynomial division. So y respect to s is equal to s plus 6. So s plus 2 is s squared plus 2s plus 2. So we have to decompose the given fraction. How we going to use that? So in our past lessons, or in our last topic in using ABCDs. So A plus 2 plus B s plus c over s squared plus 2s plus 2. So I'm going to multiply the given terms, but in cross multiply. So we will have s plus 6 is equal to a is multiplied by s squared plus 2s 2 plus bs plus c is multiplied by s plus 2. So we have a given equation. So we need to multiply given parameters. So a s squared plus 2a s plus 2a, also plus bs. We're going to use the full method here, in bs plus c times the s plus 2. So bs squared plus 2b s plus cs plus 2c. So we will group the common terms. So a plus b squared plus 2a plus b plus c is multiplied by s, and this one is 2a plus 2c. So I'm doing this to break down the problem so that you can understand. So we need to we are now going to match the coefficients of the s plus 6. So the coefficient of s squared, so is a plus b is equal to 0, and coefficient of s is 2a plus b plus c. Last one, the constant of 2a plus 2c is equal to 6. I forgot the coefficient of s is equal to 1. So we need to solve the systems. So a plus b is equal to 0. So we need to arrange the equation. So b is equal to negative a. Second part is p2a plus b plus c. So equals 1. We need to arrange this to that we have, so that we can have a proper a value. So 2a plus, so we will substitute our b. So 2 times of a plus c is equal to 1. So arranging it, our c is 1. Last part is we need to substitute that we have already gotten. So the 2a plus 2 plus 2 times 1, our a is equal to 2. Now we will arrange this. Our a is equal to 2, our b is equal to negative 2, our c is equal to negative 1. So we have our values. So we need to, we will now put this in our given equation that we derive on. So y with respect to s is equal to 2 of s plus 2 plus negative 2s plus 1 s squared plus 2s plus 2. Now we have the values of our ABCs. So we will now use the inverse Laplace transforms so that we can derive for our final answer. So let's define it in one by one. But firstly, we will need to write this in quadratic standard form. So s squared plus 2s plus 2 is equal to s plus 1 squared plus 1. So let's define first the inverse Laplace of 2 over s plus 2. The answer is 2a negative 2t, a raised to negative 2t. So now, so that we have break down the first term, we will now complete the the equation before we deriving in our final answer. So we need firstly is the second term. But how are we going to do that? So remember that s is equal to s plus 1. So negative 2, we derive the s into s plus 1 plus 3 s plus 1 is equal to s plus 1. So we will cut down one by one. Negative 2 is time and multiplied by s plus 1 over s plus 1 squared plus 1 and 3 over s plus 1 squared plus 1. How we derive by using this? So we partial fractions that we have given of 3. So we will use the inverse Laplace. So this will be transformed into negative 2e raised to t cosine of t, and the second term plus is 3e raised to negative t sine t. So we need to group the final answers that we have already gotten. So in s2 over s plus 2 we got is equal to 2e raised to negative t. So put the y Laplace transform negative y inverse Laplace. So split to t. So our final answer is, put this answer here, negative 2e is the negative t cosine of t plus 3e raised to negative t sine t. So this is our final answer. I hope you follow the instructions or understand how I derived in this final answer, and also you have an idea of solving this third linear order of different equation. It's a bit tricky if you cannot follow, but if you practice more, you can master this type of equation. I hope you listen carefully. So thank you and goodbye.